Woohoo! Welcome back. Today we're going to be talking about other types of equations that can end up looking like quadratic equations. Woo! Now, the problem with these is they won't necessarily look like quadratic equations when you first see them. For example, our first example has a radical or a square root in it. So, will you always know that's where you are? No, not necessarily. So, let's approach a couple different examples and I'll show you how to work with them. Keep in mind that because these don't start out as quadratic equations, that means that you really need to check your answers because you can end up with some really wacky answers that don't really work. So let's go ahead and get started. Woohoo! So we're starting with the radical equation. So that's any equation that has a radical in it. And basically, it's pretty straightforward to solve these because there's pretty much only one solution, and that is isolate the radical and then square the heck out of everything. So, first thing we're going to do is isolate the radical. So I've got radical x minus 1 equals 1. Oh my gosh, so many ones. What I'm going to do is, well, that wouldn't help. I could add 2 to both sides, but that wouldn't solve anything, would it? How about if I just add 1 to both sides? That probably makes a lot more sense. The reason is that then we get that 2 that my brain was trying to pop in early, and we get a 0 over here, so this radical is all by itself. Once the radical is isolated, and here the question becomes, if you've got 2 radicals, what do? You put them on either side. But that, in this case, we've just got the 1. So get the radical by itself or move radicals to opposite sides. Then we're going to square the heck out of everything. Now, when you're squaring, you have to square the whole side. So this is 2 square each side, and make sure I forgot to write that in. So that's step 2. Isolate the radical, step 1. Square each side is step 2. Make sure you're squaring each side. And I know this can be really uncomfortable. And we've got a second example that'll show, yes, it is uncomfortable, but you have to square each side. You cannot square each term. And that comes from the fact that when you square each term, you're not truly squaring the side, right? So let's go ahead and square each side. In this case, each side only has that one term, so it's a lot easier. So radical x minus 1 squared, the radical and the square undo each other. That's the whole point of squaring. So then I end up with x minus 1 on the left, and on the right I end up with 4, and I add 1. My brain. Endlessly helpful, but prone to all sorts of funny things. Sorry. So let's add 1 to both sides and then get x equals 5. Woohoo! So the rule is, with these radical equations that look like quadratics but aren't really quadratics, always check. So the third step should always be to go ahead and check. Let me move this up so you can see it. Woohoo! So let's check x equals 5. Now remember that when you're checking, you have to check in the original equation. You can't check with a fixed equation or a changed equation because you don't know where a mistake might have popped in if there is a mistake. So I'm gonna copy down the original equation, which is x minus 1 inside the square root, or inside the radical, minus 1 equals 1. So let's see, 5 minus 1 inside the radical, minus 1. Does this give us 1? So this is radical 4 minus 1. So radical 4 is 2. 2 minus 1 equals 1. Yes, it does. We're good. Yay, we got it right. And, the two little blotches of white that you see where I had to fix a mistake, hopefully that reminds you that the path to math is full of mistakes. And the trick is just to try to write big enough and catch them when you make them. And if you make one that you don't catch and something ends up weird in the check, then go back and check your work. And always, if you've got a problem where you're sure you've got the answer right, but it doesn't seem to be working, reach out to me, reach out to the tutors. We are happy to take a look at it. A fresh pair of eyes can often see what you don't see because you've been looking at it so much. So take a break, ask for some help. No shame in that. Math can be a group project. Seriously. Okay. Dun, dun, dun. Okay, this one is a little bit more awful or horrible. This one is a situation where we've got a radical, but we got a lot of other stuff going on. So 2x equals 1 minus radical 2 minus x. And what I'm going to do is I'm going to go ahead and subtract 1 from both sides so that I can isolate the radical. So that's what we're doing right there. Now, I will tell you that, you see this minus there. There's not much you can do about that. I know a lot of people would say, oh, we should move it over to the other side. You're welcome to. It will not actually change the outcome. So the solution will look a little bit different in the steps, but the actual answers we get will be the same. So you don't have to worry about that minus, except to notice that, once we square each side, and remember, it's not each term, it's each side, we are going to lose that minus. And so since you know that squaring does not preserve sign, that means that some shenanigans are going down. So this is a heavy indication that maybe one of the answers won't work out quite right. It's possible none of the answers will work out, and it's possible that all the answers will work out. You won't always see this coming, but this one, yes, if your brain's saying, whoa, what's going on here, then your brain is very smart. Give it a nice little happy, thankful pat. But let's go ahead. We've square both sides, right? There we go. That's the second step, square both sides. And then let's go ahead and take a look at what we've got. And this is what I meant before. I meant, we're going to have to do a perfect square. So either you're going to do this using the perfect square formula, or you're going to do it as 2x minus 1 times the quantity 2x minus 1, right? You can do it. You can work it out as FOIL if you want instead of a perfect square formula. So it's up to you. But you will get 4x squared minus 4x plus 1. Go ahead and pause the video if you need to. Double check that you understand where they came from. If you don't, ask me, ask a tutor, right? And then over here, now we're actually squaring two different things that are multiplied together. We've got a negative here, which is a negative 1. And that squared is just a positive 1. And then we're also squaring the square root, which ends up being just the 2 minus x. So a lot is going on here. And again, if you're looking at this going, what? Then go ahead, pause the video, come talk to the tutor, come talk to me. We'll help you sort it out. Okay, at this point, we can easily see the quadratic happening here, right? We can see this quadratic, but we're going to have to move everything over. So I'm going to subtract 2 and add x. And notice I'm being fancy now. I did them in different orders, and that's okay because it's negative 2. So I've got the negative 2 and the positive x plus x. So I've got 4x squared minus 3x minus 1 equals 0. So far, so good. Woohoo. Now, at this point, you've got a couple options. It turns out that this actually does factor. You can also use the quadratic formula because we've got a quadratic. But I want to show you the factoring version. I want to show you that this guy factors. It actually factors fairly nicely. It factors into 4x and x. And then as it turns out, it's 4x plus 1, x minus 1. You can take a look there. 4x times x is what gives us the 4x squared. And then the 1 times the negative 1 gives us that negative 1. Now, how do we get the negative 3 in the middle? We've got a plus 1x minus 4x, which gives us that negative 3x. And again, do this slowly if you're not sure what I'm saying, or pause the video, go ask for some help. You can use a lot of different methods to factor it. And you could also use the quadratic formula, which will always work. If quadratic can be solved over the real numbers, the quadratic formula will work. Okay, but I'm going to go ahead and use this. So then I've got it factored, so I use the 0 property. I've got one of those two. So let's see, this one's fairly straightforward. And then, oh, this one's ugly. 4x equals negative 1, so x equals negative 1/4. Okay, so I've got two possible answers, and I'm going to grab another piece of paper so I can check it. I could check it right there, but it feels like it's going to be a little bit squashy. So I'm going to go ahead and do my check on another page. So, and again, I'll remind you that you can check it here, but that's not as helpful. What you want to do is you want to check the original. So I'm going to go ahead and check with 2x equals 1 minus radical 2 minus x. Now, my way of facing math is to always hope for a zombie apocalypse, so I don't have to finish the check. And so whenever I'm checking, I'm always going to check the easier one first with the hopes that the zombie apocalypse will come and then we don't have to finish it, right? Okay, so let's check x equals 1. So on the left, I'd have 2 times 1. And on the right, I'd have 1 minus 2 minus 1. So over on the left, I have 2. Okay. And over on the right, I have 1 minus radical 1, which is 1 minus 1, which is 0. What happened? These two don't agree. So this is not a solution. But why? Well, the answer is when you square both sides, remember, there was a point right here where we squared this minus and the minus disappeared. Basically, when we squared it, it became a positive 1. So in effect, the equation forgot whether that was a minus or a plus. Let's take a look at what's going on here. 1 minus 1 doesn't equal 2, but 1 plus 1 would equal 2. And that's what the math was telling us. If you ask the math to forget whether this is a minus or a plus, it will often give you both, if that makes any sense. So it gave you the answer of 1 plus 1 equals 2. That's what it was trying to help you out with. So for x equals 1, it turns out what we do is we go back in and we say, nope. So when we write our final answer, x equals negative 1/4, or x equals 1, we say x does not equal 1. And we leave it like that to be the breadcrumbs to say, yes, it'll look like this is a solution, but this is not actually a solution. That is, it's an extraneous solution. When you're turning this in for homework online, you wouldn't list it at all. But if you were doing it on paper, you would leave that. You wouldn't erase it like it never existed. Okay. As much as I'm not looking forward to it because it is a fraction, I've got to check the other solution. So let's go ahead and try what happens when x equals negative 1/4, which seems so unlikely, right? But let's go ahead and try it. So on the left, I've got 2 times negative 1/4. And is that going to be equal to 1 minus 2 minus negative 1/4? Okay, over on the left-hand side, I've got 2 over 1 times a negative 1/4. So this is going to be equal to, where's my red pen of destiny? Cancel the 4, cancel the 2. I get negative 1/2 on the left-hand side. Okay, again, this is looking hopeless, and I could totally understand giving up right now, but let's not. Minus the negative 1/4 is at least 2 plus 1/4. Now, for my classes, if you're doing this for online, you have to finish it because there's no partial credit for online homework. But if you were taking this during a test, even completing this far is good for partial credit. So, get as far as you can before you're just like, bleh. But hopefully you can make it all the way. So let's keep trying. We're going to do it. We can do it. We can do it. So I've got to deal with 2 plus 1/4. So I'm going to work on that over here on the side. 2 plus 1/4 means I need common denominators. So my least common denominator, you can tell where my brain is, or my common least denominator. Let's try that again. Least common denominator, there we go, is 4. So I've got to rewrite 2 over 1 as fourths. Let's see, that would be multiplied by 4, multiplied by 4. Remember, you have to multiply top and bottom by the same thing, so I get 8/4. So 8/4 plus 1/4 equals 9/4. Okay. So over here, I get 1 minus, and instead of 2 plus 1/4, I get 9/4. So give myself a great big. Now this is awesome. I know everyone's like, it's a fraction, but it's a fraction full of perfect squares, which means I've got 1 minus square root of 9 is 3, square root of 4 is 2. And then I have to write, okay, but I'm almost done. 1 is just 2 over 2 minus 3 over 2. That's equal to 2 minus 3 over 2, which is negative. Oh my goodness. Look at that. How exciting is this? Even though it seemed really unlikely, the two sides are equal. And yeah, we have to do a lot of work to get there, but that's kind of cool. So in other words, the actual answer is either this whole thing, or you simply just put in, if you're like putting it into a computer. Computers don't understand extraneous answers, so don't try to explain it. Just give them the one that does work. Woohoo. Okay, well, I had hoped to finish the whole section, but we're already almost to 20 minutes. So I'm going to call it now, and then this will be the end of this video with our exciting check, but we're going to go into another video, a second one for 1.6, and so I will see you there. Go ahead and take a break, get something, to snack on, get some hydration, maybe go out and look at something green, and I will see you guys right back here, same math time, same math station. Woohoo, math on.